Okay, hello everyone. This is going to be the final part of the second chapter of Haskell called Hello Haskell. We covered it last time. We did most of it, so we talked about infix operators, we talked about precedence, we talked about what's a function briefly, we talked about GHCI, the interpreter, we talked about arithmetic. We talked about a little bit about modulus and remainder, how those similar, how they different. We talked about using parentheses. We got most of the chapter, but this is an important thing. It's called the let and where, right? So as you can see here, you have let and where. They're similar but also different. So like, check it out, right? Let introduces an expression, so that it can be used wherever you have wherever you can have an expression. Where is a declaration that binds it, binds that value to it, right? So what does that mean? Let's look at this one, right? Print inc n equals print plus 2, where plus 2 equals n plus 2, and then compare it to let plus 2 equal n plus 2 in print plus 2, right? So in this one, you say, okay, we have this function, it takes n as an argument, and it prints out this plus 2. Normally, if you just had this by itself, it would have an error because plus 2 doesn't exist, right? But this where lets us define it. In other words, it lets us bind a certain value, a certain expression to lets us bind a certain expression to plus 2, namely n plus 2, which is the variable here. It binds it within the scope of the function, because notice the indentation, right? Whereas here we say print inc 2 of n equals let plus 2 equal n plus 2 in print this plus 2, right? So in other words, this is saying, all right, here the where comes after, the let comes before, and the where binds this within the scope of this statement, whereas with the let plus 2 equal n plus 2, scope. So that's like the scope of it, right? Let's see what we mean here. Give me a moment. I'm gonna I'm going to do this. I'm going to move these to different screens. We're going to write these functions out. I'm going to show you. If you don't completely understand it, it's okay. I just want to briefly introduce the item right now, all right? Function with where. So let me, yeah, I was watching The Sopranos. All right, I'm going to pause the video real quick. All right, now we're recording again, so this is going to be print. I think this is let n equal let plus 2 equal n plus 2. And what did this say? In print plus 2. So now we're going to go over to our trusty GHCI compiler, and we're going to do it so. So we're going to okay, and we're going to say print inc. Hold on. Print inc 1 is 3 because it's n plus 1. All right, so let's try L function with let. There we want to do. Print inc 2 1. Oh, yeah, I changed that to the number 2. So let's do this. Let's do that, and it's the same thing, right? But then what happens if we try to do a print inc 1? It doesn't work if we try and do it here. So if you look at the source code, I did change it to print inc 2 so I could show you this. When you load something in the GHCI, it wipes all the other modules that you previously loaded. It doesn't remember. So therefore, this is okay right now, and all we got is one module, but you want to start making a complicated program with the different modules and libraries. GHCI is not going to cut it. That's the point we want to make here. So let's clear that. Cool. So hopefully that makes sense. If the let and the where didn't make sense, we'll circle back around to it. It's quite all right. So let's see. Exercises, right? So for some exercises, we're going to determine in your head. So we're going to look at these expressions, and I'm going to ask you to pause the video, and then we're going to validate that in the REPL, right? And yeah, let's pause the video, and then we'll go over it. All right, hopefully you paused the video. So you got these, and you've written down your answers. Let's test them out. Let x equals 5 in x. So I think this is going to return 5. What do you know? Let x equal 5 in x times x, 25. Let x equals 5, y equals 6, and x times y, 30, right? It's pretty simple. And then we also got this one, right? We're going to try that one out. Pause the video, think on it for a second, unpause it, and let's go back. All right, let's try it out now that you pause the video. It's going to be 6. So you can say let y equals 1,000, but we never call the value, right? Okay. We're going to do the same thing here. So what it says here is, so there we did REPL. We're going to redo a file, right? And we're going to rewrite the let expression with a where declaration. So here's an example, right? So here's this statement, what we did earlier. If we wanted to rewrite it in a module, it would look like this. It would say module molt1 where, this is what you put in the file, right? Molt1 equals, and notice how the equal signs all line up. It says right, that's a stylistic choice. As long as it's consistent and it's indented is what matters. It's consistent. That's what the interpreter cares about, right? So, but it just looks nice this way. So see how they replaced it, let x equal to 5, y equal to 6 in this? They turned the let statement into a where statement and so they said this function equals x times, or this value, excuse me, equals x times y, where x equals 5, y equals 6. And they load it and it returns 30, right? So we're going to pause the video. There's 3 problems like this. We're just going to do 2 of them because they're pretty simple. So pause the video, and then we will go to it. All right, hopefully you did the video. So now we're going to pull these over here. I'm going to type it out so you can follow along with that. So this will be practice.hs module molt2 where Let's actually call it the molt module. Molt 1, molt 2, because we already did molt 1. So you have x equal to 3, y equal to 1,000, x times 3 plus y. So it'll say molt 2, we'll give it a few spaces, equals x times 3 plus y, where x equal to 3, y equal to 6. See, everything is nice and neatly lined up. It's consistent. That should work. The second one was let y equal 10, x equal 10 times 5 plus y in x times 5. So we're going to say molt 3 equals x times 5, where we're going to say y equal to 10, x equal to 10 times 5 plus y. And then we're just going to do those problems because these are all pretty much once you get the idea of it. I'm going to bring this over here. This is going to be practice.hs. We're going to load it. Practice.hs. OL/practice.hs. Okay. Molt 2 is 15. Molt 3 is going to be 300, which makes sense because if we go back to our formulas here, that's what we expect. Oh, I typed in the wrong number. That's why it's not doing that right. Silly me. But this checks out because, again, remember, yeah, 10 times 5, that's 50, plus 6 is 60 times, so 10 times 5 plus y, y is 10, so that's 10 times 5 is 50, plus 10 is 60, and x times 5, 6 times 5, it's the same thing. We get it. Now we got chapter exercises, right? Given what we know about the precedence of these, how can we parenthesize the following expressions more explicitly without changing their results? So they want you to be very explicit with the parentheses, right? Oh, I think I forgot to tell you about $sign the last time. Let's do that. So $sign is just another way of doing parentheses, basically. It means everything to the right is evaluated last. So let's see. 5 plus 3 times 2. So that's 5 plus 6 should return 11, right? 5 plus... That's 5 plus... There's $5 plus 3 times 2, I think. Oh, I had the order the wrong way. So it should be... I think it should be like that. Hold on, I'm tripping myself out here. Give me a moment. I'm going to pause this while I figure it out. Okay. Okay, I figured it out. So we're going to Let's use the example from the book here. It's a little bit harder with the arithmetic operations, but remember we said 2 times 2, right? So that's just 2. It's what we call partial function, which we'll talk about that later. 2 plus 2, right? Cool, because that's that parentheses on the right. This right here evaluates to 4, then 2 to the power of 4 is 16, right? But instead of putting parentheses here, what we can do is 2 $2 plus 2. It's the same thing. So this says, it has the same effect as parentheses. It says, all right, we evaluate this part first is what it means. And you use it mostly with functions. So if we go back to the chapter exercises here, now that we did that, and we have an idea what $sign means, because I forgot to cover it last time, let's be a little more explicit, right? Pause the video, think about the parentheses. Okay, hopefully you pause the video. So for the first one, 2 plus 2 times 3 minus 1, 2 plus 2 times 3 minus 1. It's the same thing, right? Because this is a higher infix rating than this or this. Easy enough. Next one. $1. So that says, all right, this function is going to take 10 and raise it to the power of 1 plus 1, just 10 squared, 100, right? Remember, we said $sign. Can you just think of that as like another way of saying parentheses? So remember, when we put an infix operator in parentheses, it becomes like another function, like a regular function that takes 2 arguments. Now, that proves that's the same. The second one was 2 power of 2 times 4, 5 plus 1. So this is going to evaluate to 4. This is going to evaluate to 4. I don't know, let's see. 4097, right? So in other words, 2 times 4, 5 plus 1. It's just making it more explicit, right? Now this one says equivalent expressions. Which of the following pairs of expressions will return the same code result when evaluated? Reason them out by reading the code. Don't just cheat and put it into the REPL. Think of it mentally. Pause the video. Think of it mentally. Unpause and we'll check our work. Okay, so you unpause the video. Hopefully you did this on your own. Number 1 is 1 plus 1 and does indeed equal 2. Number 2 is 10. 2, that's going to be 100. 10 plus 9 times 10. So this evaluates first, and 90 plus 10 is going to be 100 as well. 400 minus 37, 363. Now this one, we turn that into a regular prefix operator. Let's think about what this is saying. This is saying take 37 and subtract 400 from it. Because remember, this is just equivalent to moving. This is the same as if we had the minus right there. So in other words, this is going to be negative 363. See how that works? 100 div 3. Is that going to be the same as 100 divided by 3? No, because the slash division returns a float, whereas div returns an integer. Remember. And notice how it rounds up to 6 at the end here. That's a oddity of floating point arithmetic. I'll be honest, I don't understand it 100%. But 5 plus 18 is going to be 28. And then we have 2 times 5 plus 18 is not going to be 28 because The parentheses means this is evaluated first, whereas in this expression, the multiplication evaluates first. 46, exactly. Now we have something called more fun with functions. Here's a bit of code that might be entered into a source file. Remember, the order in a source file does, and GHCI it matters. In the interpreter it doesn't, right? So we're going to evaluate this into the REPL. We have this code, right? Now you have a value called wax on in your REPL. What do you think will happen if you enter these things? So pause the video and think through it, and then let's find out. Hopefully you pause the video, clear the screen there. Z equal to 7, X equal to Y. Don't be tempted to cheat, because you're really just cheating yourself. Make sure that, oh yeah, that's... Oh, we have to rewrite it. Okay, never mind. I misunderstood the... Okay. So we have those statements. So the first one we want Z equal to 7, because that's just an integer, right? And then we want Y equal to Z plus 8, because now we've defined Z, so now we can get Y. And X is equal to Y 2, which makes sense because we are able to define Y because it contains Z. And we have wax on equals X times 5. So that's how you would rewrite them. So now when we get 10 plus wax on, it's going to give us 1,135. 7 plus 8 is 15. 15 squared is 150 plus 7, 225. 225 times 5, I believe, is that. Or, same thing there. Oops, we shouldn't have done the or there. See, these are different because this is not an abelian operator. So this one says, number 2, and on your REPL is the wax on in session, re-enter the triple function at the prompt. So we're going to try that. What do you think is going to happen? Interesting, because remember, we already bound X to something here. So what if we do, now it says number 3, what will happen if we enter this at our GHCI prompt? What do you think will happen first, considering what role wax on is playing in this function call? Enter it and see what it does. Check your understanding, right? So remember up here, we just 7 plus 8 is 15. 15 squared is, I believe we said 225. And then that times that is going to be 1035, right? 1035 is going to be our answer. Triple wax on. It's going to be 3375. The reason it works this way is because, yes, X is bound here, but in the context of the function, X could be, in other words, you could write that function as triple Y equals Y times 3. Triple wax on. Because the X is not, doesn't care about what X is outside. It's just a dummy variable. We call that an alpha. I believe it's the alpha reduction. Meaning it could be X, could be a Y, could be a Z, could be a A, B, whatever, right? That's only in the scope of this function. Outside of this function, X is still bound to a value. Hopefully that makes sense. So now let's see number So this is rewrite wax on as an expression with a where clause in your source file, load it into your REPL, make sure it works as expected. All right. Pause the video and figure that out. All right, we went ahead and did that. This is how I did mine. So again, even spacing, so equals x times 5, where x is this, and because it's in the file, it doesn't really matter. So we go here, I already loaded it, wax on plus 10. Very cool. All right, we're almost done here. Says now, without changing what you've done so far in that file, write a new function called waxoff that looks like this. So okay, to double check my work there, but yeah, we just did that. We did that. Let's load her up again and see what happens. Chapter 1 / so wax off. What does it want us to do here again? We did that. All right, load the source file, wax off, wax on. So we'll do wax off, wax on. That's pretty much it there. What if we do wax off 10, we get 30, wax off, -50, we're going to get -150, right? See how that works? Calling functions and other functions, we're going to get into that, I believe, in the next chapter. We'll end the video here. This is the end of part 2. Next time, we'll begin covering some actual data types, strings. Anyways, thanks for watching. Like, comment, subscribe, and all that. If you have any questions, leave them in the comments, whatever. And see you next time.